Welcome to Grateful, where we provide online instruction for students all around the world. If you're interested in figuring out how we can help you prepare for your next SAT or ACT, reach out and we'll be sure to get back to you as soon as possible. Right now, we're talking about A-B factoring, which is one of the many things that you shouldn't set foot in an SAT without knowing how to do. Let's just quickly talk about the structure of a quadratic. A quadratic generally will be found in the format of ax squared plus bx plus c. So if I have a polynomial like this, x squared plus 5x plus 9, well, there's a b there and a c. So that would be called BC factoring, and there's a method for that. If we see numbers in all three of those spots, so let's say we have a 4 right here, well, that is ABC factoring, and there's a method for that, and you should know that as well. Right now, we're talking about situations where we have the first and second numbers, but not the third. So something like this, we would call AB factoring. And it does come up a lot on the SAT. You do want to be certain that you know what to do if you encounter a situation like that. So let's look at a couple of examples. So here we have an A-B factoring situation. We have an x squared and we have a 5x. And so to solve that, what you need to do is get the GCF. So for A-B factoring, the greatest common factor is the most important thing. So what's the GCF between x squared and 5x? Well, both of them have an x. So if we factor out x, it'll leave us with x plus 5. So we just replace the given expression with something that's equal to it. And now we can use the zero product rule. The zero product rule says that if this thing times this thing equals 0, which apparently it does here, then we can go ahead and set each individual piece equal to 0 and solve. And so therefore we'd get 0. And if we take away 5 right here, we'd get -5. So the answers in this situation would be 0 and -5. Looking at a slightly more complicated example here, we've got 3x squared minus 18x equals 0. And so our formula for this is to get the GCF and then use a zero product rule. So what's the greatest common factor between 3x squared and -18x? That would be 3x. And if we factor out 3x, it would leave us with x minus 6. So now we can do the zero product rule, set each individual piece equal to 0. And here we can divide by 3 to solve. So x equals 0. Here we can add 6 to solve. So x equals 6, and we're done. Another example here. This one's the same idea, but it's not formatted yet the way we would need. So what we have to do is just basically subtract 10x from both sides. And now we have x squared minus 10x equals 0. And this is the common structure for our AB factoring. So we can take out the GCF, which is x in this situation, leaves you with x minus 10. And then we go to the zero product rule again, where we're just basically going to set each piece equal to 0. Here we're going to have to add 10 to both sides, and we'll get x equals 0 and x equals 10 as our two answers there. So nice and easy, just something to add to your vocabulary. And that's the general idea of how you want to excel on this current SAT, by knowing everything that's required and having them at your fingertips. Yeah, there may be some hard questions, some puzzling situations, and there will always be those out there, but there are enough things that are nice, easy to handle, and that you owe it to yourself to know how to do before you set foot in an SAT. So on this one, initially, we may not necessarily realize that it's A-B factoring, but as we start simplifying, we should really be saying to ourselves when we first see this question, well, this is a quadratic because it has an x squared and an x, and those are things common to quadratics. And for quadratics, you set them equal to 0. So what we're doing right here is we're doing the opposite of the 2x squared, and we're doing the opposite of the 10x, and that's going to kind of get a 0 on one side, which is, like I said, the standard thing you should be doing for quadratic situations. So right now we've got 2x squared minus 16x equals 0. The common factor between these two terms is 2x. So if we take out a 2x, it'll leave us with x minus 8. And if you need help factoring out GCFs, we've definitely talked about that in previous videos, or maybe even looks elsewhere besides gradeful. Factoring out a greatest common factor from a polynomial is absolutely important. Maybe at some point in the near future, we'll do another video on that. But right now we have the zero product rule, 2x equals 0, x minus 8 equals 0. And now we can divide by 2 on both sides, add 8 to both sides, and our answers are 0 and 8. So now, by the way, what are we talking about? We're talking about the idea that this is a parabola and this other one on the right is a parabola. And where do they intersect? They intersect at those two x values at 0 and 8. And, who knows if one of them looks like this and the other one looks like that. I'm not actually graphing them right now, so I don't know. But the point is that we're trying to figure out where they hit. Maybe the place where they hit is not really maybe it's not necessarily on the x-axis. Maybe it's up here or somewhere else. So, just to get a visual image, you may have one parabola that looks like this and the other one that looks something like that. But we're finding out where is it that they hit. And if we take either of these answers and plug them in, we'll get the two y values of where they hit. So let's just, for the sake of argument here, go ahead and find out where these two functions actually hit. I would plug in the x equals 0, so into either side. So now, what are we doing? We're seeing as if this were one y equals, this is one function in green here, y equals 4x squared minus 6x, and this is another y equals, because if you're ever given two functions like that and asked where they intersect, the right thing to do is to set them equal to each other. So what we might see in green, purple, and blue here is the second step of finding the intersection between those two functions. But if I go ahead and plug in x equals 0 to the first one, we'll get 4 times 0 squared minus 6 times 0. And that does come out to 0. So we just found out that 0, 0 is the first place they hit. And if we plug in the 8, we would get 4 times 8 squared minus 6 times 8. And so that's 4 times 64. 4 times 64 is 256 minus 48. And whoa, we have a crazy answer, 208. So where do these two functions hit? They hit at 0, 0 and 8, 208. So what would that look like? I don't know. We've got a parabola that looks kind of like that, maybe. And maybe another one that looks like this. But whatever the case, we found out that they're hitting at those 2 points. And that's kind of the more in-depth explanation of what it is you're doing when you set two things equal, you find the x values for where they intersect. And if you wanted to, you could plug those back in to find the y values of where they intersect. Now, these are not the actual graphs, but just to give you a mental image, they could look something like that. So let's go ahead and keep going, focusing on our A-B factoring method. So here we have, let's just go ahead and get rid of this one for now, so it's not taking up our visual screen here. So for number 5 here, we've got the graph of this function intersects the graph of another function at 0, 0 and CC, find C. So as I was saying a moment ago, if we have an intersection, a high level intersection, something involving a parabola, the one-liner is get them both in the y equals format and set them equal. So these are already in the y equals format. And so we want to do 4x squared plus 24x and set it equal to 2x. Now the instinct is to know that this is a quadratic. So we want one side equal to 0. So I'm going to take away 2x from both sides. So right now we've got 4x squared plus 22x equals 0. And now we're at our AB factoring stage. So let's go ahead and take out the greatest common factor, which is 2x parentheses, and that would leave you with 2x plus 11. And now we're going to do the zero product rule where we set each piece equal to 0. and divide by 2 on both sides. Here, you're going to take away 11 from both sides. And we get negative 5.5. So those are the two x values where they intersect, 0 and negative 5.5. So what's the other x value where they hit? Negative 5.5. And for any of the real math scholars out there, if you've already realized that this point can't also be C, or most likely is not also C, then good job for you. A little typo in the question itself there. Because if we plugged in negative 11 over 2 back into the original function, there's almost no chance it's going to come out to y equals negative 11 over 2. So a little issue there. But the idea is we set them equal. We did A-B factoring. We got our two values of x, and that's the process. And, these are the kinds of questions you'd see on the SAT. So let's see if we have any others here that we can use. I think one kind of disappeared in the mix of getting this ready. But that should be it. So if you've paid attention to this video and followed along with the steps, then you know A-B factoring and you're one step closer to a great score on the SAT. Thanks so much for watching. Have a great day.